I've talked about the infinitely large. What about the infinitely small? Is space infinitely divisible? Or is space perhaps made up of space atoms, indivisible units of space? The difficulty is that there are going to be problems either way. Let's first take the famous problems about space being infinitely divisible. Well, perhaps the most famous problem of all was the problem propounded in the 5th century BC by Zeno, 26 centuries ago. This is Zeno from Elea in Italy, a Greek-speaking Zeno. It's not the other famous Zeno who founded Stoicism a little bit later. Zeno of Elea raised the sad problem that unfortunately none of us can go home tonight, indeed none of us can reach the door. Because in order to reach the door, we would first have to go halfway, then a quarter of the way, then an eighth of the way, then a 16th of the way. In fact, we would have to finish going right through a more than finite number of subdistances. How could one finish going through an unending number? Well, I briefly mentioned this sort of problem last week, and I have mentioned it in the past. But I think I can make it harder than I've made it before. Here's a way in which it will seem harder still, I believe. Would it even be enough if we could finish going right through an infinite number of subdistances to the door? Would that even be enough? After all, not one of those distances will reach the door, not the quarter way which I spoke about, not the 1/8 way, not the 16th. You take any fraction in that series, as small as you like, it won't be the one that reaches the door. There isn't a fraction in that series that reaches the door. If you think there is, if you think the millionth member of that series reaches the door, I can tell you that there's an infinite number of further fractions beyond that. And none of those reaches the door either. That's a bit startling. And yet I think we can also see that if you take the series as a whole, the series as a whole does reach the door. The series a half, a quarter, an eighth, a 16th, taken as a whole does reach the door. And here's how I'd show this. If you think it falls short of the door, I'll ask you how much you think it falls short. 1/millionth of an inch? No, if you say 1/millionth of an inch, I could, with paper and pencil, or somebody quicker at mathematics than me, I could tell you exactly which member of the series got closer than 1/millionth of an inch. Oh, well, what about 1/billionth of an inch then? No, exactly the same reply applies. With a good arithmetician in the audience, we could tell you which member of that series, half, a quarter, an eighth, is the one that gets closer than 1/billionth of an inch. You can't mention any distance by which the series as a whole falls short of the door. So now we've learnt something pretty astonishing, really, initially astonishing. No member of this series reaches the door, and yet the series as a whole has to reach the door in the sense that it can't possibly fall short. Now, how can this be? I mean, if the crowd in this room reaches the back door, as it does, it must be that at least one member of this audience reaches the back door. That's what we're used to. But what I'm saying is that that doesn't seem to apply to an infinite number of segments. What I've been saying is we can show that no segment in that infinite series reaches the door, and yet the series as a whole reaches the door. So an infinite series of things seems to behave quite differently as regards reaching the door from a finite collection of people. Why is that? Well, perhaps it shouldn't be so surprising because of something I said last week. Last week I said that infinity belongs to the whole series, but doesn't belong to any member. You see, I was saying last week that if there's an infinite past, that doesn't mean that there's some past year which was separated from now by infinity. I said last week that infinity isn't a property of any member of the series. Infinity is a property of the series as a whole. Now, if that was right, it perhaps shouldn't be surprising, or not so surprising, that reaching the door is also going to be a property of the series as a whole, but not of any member of the series. The series half, a quarter, an eighth, a 16th, and so on. Perhaps that makes it clearer why the series as a whole could reach the door, even though no member does. We're learning things then. In trying to wriggle out of Zeno's problem, we're learning things, and I'll just say one last thing. Supposing we numbered the half, the quarter, the eighth, the 16th, so that, supposing I number them as 1, 2, 3, 4, 5, 6, and so on. Now, when we've actually reached the door and looked back at our achievement, will the odd-numbered segments be closer to you, or the even-numbered segments, would you say? Well, it's rather difficult to get a nice answer to that, because if you think the odd number segments will be closer to you, I'll ask you, I'll ask you which one you think is closer than the even segments. Whichever one you'll name, I'll be able to show you, oh no, there's an even-numbered segment closer than that. And of course the other way around too. If you think the even-numbered segments are closer, I'm going to be able to show an odd-numbered segment that's closer than the even-numbered segment you thought of. The truth of the matter is that it isn't that the odd-numbered segments are closer, and it isn't that the even-numbered segments are closer. Neither is right. So I think that what is happening here is this. We don't have to accept Zeno's own conclusion. Zeno's own conclusion was that we couldn't go home. We couldn't reach the door. Indeed, you can't even wag your little finger. Now, we don't have to accept that, which would be a very startling conclusion. But we are forced, before we can say goodbye to Zeno, to learn some very startling things, like the ones I've just been mentioning. And that's why, even 26 centuries later, philosophers simply don't agree with each other about how to answer Zeno. I'm simply telling you my opinion, that we shouldn't agree with him that we can't move, but we do have to accept some surprising things which I've been mentioning to you. Now, there is an alternative. If you don't like these surprising things, then perhaps we should go for the alternative view that space isn't infinitely divisible, but you get down to a size that's small enough, and it doesn't make sense to talk of something smaller than that. Now, this is a minority view among physicists. It's not the majority view. It doesn't follow from quantum physics, for example, but some physicists have thought this was true. For example, they've said, when you measure things, you're always using light, and light behaves in such a way that it doesn't make any physical sense to talk about distances smaller than the ones you could conceivably measure. It's not because our tools aren't yet good enough. It is that whatever we did with our tools, light just doesn't behave in this way. Light behaves in such a way that if you ask questions about a smaller distance than such and such, light simply won't give you any measurements about that, whatever your instruments are. So Zeno's paradoxes then would have to be asked about mathematical space, but not about space as it really is in the physical world. Or perhaps Zeno's paradoxes could be asked about space as it might have been, but not about space as it actually is in the physical world on this view. Now, that would get us out of Zeno's paradoxes, because the answer would be that there isn't an infinite number of spaces between here and the door, and so it might seem to be the better route. All right, we'll have atomic, indivisible spaces. But this too would contain its surprises. For example, if there are atomic spaces, then how would you travel through those spaces? You'd have to travel in the following way. By disappearing, or the tip of your nose would have to disappear from one of these indivisible spaces and reappear in the next indivisible space without ever having been part way through the first indivisible space. Because what's being alleged is that there's no sense to the idea of part way through an indivisible space. That's the whole idea of an indivisible space. It makes no sense, or no physical sense anyhow, to speak of part way through an indivisible space. Well, that would mean that we were unexpectedly discontinuous beings. When we move by making microscopic disappearance tricks, like a figure on a cinema screen. Of course, that's exactly what happens, and I think I mentioned this before, on a cinema screen. It looks like smooth, continuous motion, but really the figure is disappearing from one spot and reappearing microscopically further on. And that's how we'd have to move, discontinuously. That would be very startling. I don't believe it would actually be impossible. Not many physicists believe this, but it would be possible. Aristotle thought of this in the 4th century BC, and he said it would be impossible, because he said all you could say was that somebody had moved into the next indivisible space, but you could never say of the person, now they are moving. Because to be moving, you would have to be part way through the invisible space, and the indivisible space doesn't have a part way. But somebody just younger than Aristotle, a younger contemporary, Diodorus, said, but look, that's common. It's quite often that we can say something has happened, even though there's no point at which it would be true to say it is happening. He gave a very everyday example. The beautiful Helen of Troy is supposed to have had 3 husbands, one after the other, I'm happy to say. And says Diodorus, here's a trivial example. One can certainly say of Helen, she has had 3 husbands, but there was no point at which it was true to say she now has 3 husbands. So it's commonplace every day. There are lots of things of which we can say such and such has been the case, though there was no point at which it is true to say it is now the case. So there's no linguistic objection to it being true that people would have moved by one of these microscopic disappearance tricks, even though there was no moment at which it was true to say they are now moving halfway through an indivisible space.